Hi, welcome to Sunil Maths tutorial. Again, this is a question from CSIRNet June 2023 Part B question. Consider the variational problem jy of x is equals to integral 0 to n 0 to 1 y dash square minus y into mod y into y dash plus xy dx, where the two boundary conditions are there. Y of 0 is equals to 0, y of 1 is equals to 0. Then which of the following statement is correct? The problem has no stationary function. It has only one stationary function for p. P has unique stationary function and y is identically equal to 0. P has infinitely many stationary functions external. So let us solve our problem. So here you observe that j is given by integral 0 to 1 y dash square minus y into mod y minus y into mod y into y dash plus xy into dx. And again there are two boundary conditions. One is y of 0 is equals to 0 and the second one is y of 1 is also equivalent to 0. So right here, for depends upon mod y, we treat it as positive and we treat it as negative. So we solve the problem in two cases. Case 1, let us see case 1. We treat mod y as positive. Then the integrand f becomes mod y dash square, sorry, not mod, y dash square minus y square y dash plus xy. Then Euler equations. Then Cauchy-Euler equation becomes dou f by dou y minus d by dx of dou f by dou y dash is equals to 0. So whenever mod y is positive, so f becomes y dash square minus y square y dash plus xy. Then Cauchy-Euler equation becomes dou f by dou y minus d by dx of dou f by dou y dash is equals to 0. Here f is there, so you can calculate dou f by dou y. If you differentiate with respect to y, you get the first term is 0 and the second term is minus 2y y dash plus, and you are differentiating with respect to y, so you get plus x also, plus x. So dou fy dou y becomes minus 2y y dash plus x minus d by dx of, now you are calculating dou f by dou y dash here, dou f by dou y dash, again you get 2y dash, again you get 2y dash minus you are differentiating with respect to y dash minus y square minus y square, that's it, you get 2y dash minus y square, 2y dash minus y square is equals to 0. So I repeat this differentiation clearly to understand once again. What is f? F is equals to y dash square minus y square y dash plus xy. If you are differentiating with respect to y, dou f by dou y. Here there is no y, so it becomes 0. Here it is y minus 2y y dash plus here is also y, you get x. Similarly, dou f by dou y dash, you get 2y dash. Here 2y dash you get 2y dash minus, from the second term you get y square. Here there is no y dash, it becomes 0. I write the same here. So minus 2y y dash plus x minus d by dx, 2y dash minus y square is equals to 0. Now continue the calculation. Minus 2y y dash plus x, Again you are differentiating with respect to x. So this becomes 2y double dash 2y double dash plus 2y y dash is equals to 0. The first and last terms are same, so they get cancelled. So we get simply x minus 2y double dash is equals to 0, which implies y double dash is equals to x by 2. On integrating both sides, you get y dash is equals to x square by, on integrating we get x square by 4 plus some constant a. Again integrating you get y is equals to x cube by 12 plus ax, some integral constant b. So therefore we get a function, y of x is equals to x cube by 12 plus ax plus b. Let us use the boundary conditions. The first boundary condition is y of 0 is equals to 0. If y of 0 is equals to 0, the above equation gives us 0 is equals to 0 plus b. This implies as the constant b is equals to 0. Now what is the second boundary condition? The second boundary condition is y of 1 is equals to 0. If you apply the second boundary condition y of 1 is equals to 0, you get 0 is equals to 1 by 12 plus a. 1 by 12 plus a. This implies as a is equals to minus 1 by 12. So b value 0 and a value minus 1 by 12. Then this y of x takes the form, y of x is equals to x cube by 12 minus 1 by 12 into x. You simply get 1 by 12 into x cube minus x. So here you observe that there is no arbitrary constant. There is no arbitrary constant in the solution. There is no arbitrary constant means it has unique solution. It has unique solution according to this functional or according to the Euler's equation. So unique solution means in our problem, option C is correct. P has unique stationary function extremal y not identically equivalent to 0. Yes. Option 3 is correct solution. Option 3 is correct solution for our problem. So observe that. Option 3 is correct. So this is all in positive case. We consider here mod y is positive. So let us treat the second case. Suppose you treat that mod y is negative. Mod y is negative. Then the integrand f takes the form. Y dash square plus y square y dash plus xy. In this case, again the Cauchy-Euler equation becomes dou f by dou y minus d by dx of dou f by dou y dash is equals to 0. Dou f by dou y means 2y dash plus x minus d by dx of 2y dash plus y square is equals to 0. After simplifying we get 2y dash plus x minus 2y double dash minus 2y dash is equals to 0. Again you observe that both the terms, the first term and last term are same with opposite sign, they get cancelled. X minus 2y double dash is equals to 0. You get 2y double dash is equals to x. You get y double dash is equals to x by 2. I think you get the same equation in first case also. Here you observe that y double dash is equals to x by 2. So whenever mod y is either positive or negative, we get the same solution and it has unique solution. That's it. And the unique solution is not equals to 0 also. So option 3 is the correct option. Keep learning.